Okay guys, here is our study guide, and we're just going to go ahead and work through it. Hopefully this eliminates questions that you have on the test tomorrow, or today, or whenever you decide to watch this video. But first we're going to convert each angle in degrees to radians. Now with 30 degrees, we look at the unit circle, and with 30 degrees, that ends up, if you look at your unit circle, being pi over 6. Okay? Now, with 90 degrees, or negative 90 degrees, and I'm going to pull up the unit circle here real quick. And with this unit circle right here, there it is. With the unit circle right here, if you look, here's 30 degrees, that got pi over 6. Now this is positive 30, positive 45, positive 60, positive 90. If we went negative 90, negative 30, negative 45, negative 60, negative 90 here, which essentially, if you think about it, is 360 minus 90, gives us 270 degrees, which is 3 pi over 2. So negative 90 is 3 pi over 2. Okay, so 3 pi over 2. Now, with 270 degrees, once again, you have 3 pi over 2. And with 225 degrees, you end up with 5 pi over 4. And that's all you do. Now, if we're converting from an angle in radians to degrees, we do the opposite way. Pi over 6, then that ends up being 30 degrees. 5 pi over 4, if you can't remember, come here. It's 225 degrees. Negative 7 pi over 4, once again, here is positive 7 pi over 4 right here at 315. So negative, we would have to go the opposite way, which ends up being just pi over 4, which is 45 degrees. Okay? Now, this next question, a little bit different. 16-inch pizzas cut into 8 slices. If each piece is cut at the exact same angle, what's the area of each slice? So we have our pizza. Okay, and if we cut it here, it's now cut into 2 equal slices. Cut it here, it's in 4 equal slices. And then if we cut it here and here, that's 8 equal slices. Now, we want to figure out the area of one slice. Now, if you think about it, a circle has 360 degrees. One slice, well, if you go by the unit circle, is 45 degrees. So to find the area, all you really, there's a couple ways you can do this. The first way is probably a little bit simpler way. Is basically you have your area of the circle, which is pi times the radius squared. Okay. Then you divide it by how many equal slices there are, which is 8. Okay. Another way which you can do this, if you don't have a picture representation, or if maybe it's cut into 9 equal slices and you really can't do this, is to do 360 pi r squared over our degrees. Okay, so in this case, it would be over 45 and our degrees would be up here, 360 would be down here, so our degrees is 45, 360, 45 goes into 360 8 times, so it's pi r squared over 8. Okay, so these are the same thing. So what's our radius? Well, it's a 16-inch pizza, and that's all the way across, so that is 8. So pi times 8 squared over 8 ends up being pi times 64 over 8, which simplifies to be 8 pi inches squared. Or if you multiply that with, I don't have a calculator in front of me, so I'm just going to use 3.14. You should have a calculator. So just a little over 25 inches squared. Okay. Now this next one says find the 6 trig functions following the right triangle. Okay. So first off, I'm going to label this guy A and this guy B. You could label it either way. Now the 6 trig functions are sine of A, cosine of A, tangent A, sine B, cosine B, and tangent B. Now, sine A is this angle here, and sine is opposite, which is 12, over hypotenuse, which is 13. That's all you do. Cosine of A, adjacent, 5, over hypotenuse, 13. Tangent is opposite, 12, over adjacent, which is 5. Sine B, which is this angle here, opposite 5, hypotenuse 13. Cosine B is adjacent, 12, over hypotenuse 13. And tangent ends up being 5 over 12. And that is how you do the front side. Now flipping to the back side, it can get a little bit more challenging. Not terribly too much. Okay, so here we're given cosine equaling 1 over 3. So cosine of theta is, what happened? Now cosine of theta we know is 1 over 3. So we have this triangle where if this is theta, adjacent's 1, hypotenuse is 3. Now we need to find what x is to give us our other 5. Sine of theta, tangent of theta, sine of, I'm going to call this, I'm going to just give this a pi symbol just because I want to. Cosine of pi, tangent of pi. Okay, and really, it all depends on your interpretation. These trig values could even mean secant, cosecant, cotangent, which I will just do for theta, just so you can see them. And I'll let you know. I'll give a chart where it says sine, cosine, tangent, secant, cosecant, cotangent, that sort of thing. So if cosine is 1 over 3, we need to find what x is. So a squared, b squared, c squared, 1 squared, x squared equals 3 squared. So x squared is equal to 8. So x equals 2 square root of 2. So sine is going to be 2 square root of 2 over 3. And tangent is going to be 2 square root of 2 over 1, which is just 2 square root of 2. Sine of pi is just going to be this flipped. 1 over 3, 2 square root of 2 over 3. And then this is going to be 1 over 2 square root of 2. Now you can't have the square root of 2 on the bottom, so I'm going to multiply by square root of 2 on the top and the bottom. Leaves us with square root of 2 over, well, square root of 2 times square root of 2 is just 2, and 2 times 2 is 4. So that would be the answer for tangent pi. Secant is cosine flipped, so 3. Cosecant is this guy flipped, which is 3 over 2 square root of 2, which remember we can't do that, so times top by square root of 2, bottom by square root of 2. So that gives us 3 square root of 2 over 4. And cotangent ends up being if we flip this, should be 1 over 2 square root of 2 times square root of 2 times square root of 2. So it ends up being square root of 2 over 4. Okay? That's how you do this one. And like I said, I'll let you know how to do it without a calculator, of course. If you're going to use a calculator, plug that into your calculator. To do secant, it's 1 over cosine of 41. And that'll yield yada, yada, yada. I don't have a calculator in front of me. I trust you can do that on your own. Now, to find the exact value of 2 sine 45 plus 4 cosine 30 without a calculator, that can be, at first, a little challenging. But if you remember sine of 45 from our unit circle, sine of 45 is our y value. So 2 sine of 45 is going to be 2 times sine of 45 is 2 square root of 2. Plus 4, now cosine 30, remember it's your x value. So cosine of 30 is our square root of 3 over 2. So I have this here. And this is over 2, sorry. So this ends up being 4 square root of 2 over 2 plus 4 square root of 3 over 2, which we really could say is the same as 4 square root of 2 plus 4 square root of 3 all over 2, which would simplify. This would be 1, 2, and 2. So we could really say this is 2 square root of 2 plus 2 square root of 3. And that's your final answer. Now, number 8 says to the point 2, negative 3, if the point 2, negative 3 is on the terminal side of the graph, find the exact value of the 6 trig functions. Well, if you remember, we have our graph, and if our point is 1, 2, negative 1, 2, negative 3, it's right here. Okay, so our graph, let me see if I can find a different color. This is black, it went all the way around to here. So our angle that we're using is here. We need to find the 6 trig functions. Now, if you look, here's our triangle. Here's our right triangle. And so what we have, this point here is 2, -3, and I'm actually going to draw this a little bit bigger. So this is 2, -3. So this right here is 0, 0, and this right here is 2, 0. So for our triangle, we want to find our 6 trig functions. So this length is 2, this length is 3, and 2 squared plus 3 squared. So 4, 9, so it ends up being the square root of 13. So square root of 13 goes here. Okay, so for our 6 trig functions, I'm going to do sine, cosine, tangent, and we're going from this angle A here, and then we're also going to have, move this a little bit, we're also going to have cosecant, secant, and cotangent. So sine of A, which is this guy right here, 2 over square root of 13. Remember, we can't have square root of 13 on the bottom, so this will end up being 2 square root of 13 over 13. Cosine is 3 over square root of 13, so saving a little bit of the math, it'll be 3 square root of 13 over 13. And tangent, opposite adjacent, 2/3. Cotangent is that flip, so 3 over 2. Sine, or cosecant, is that flipped, so where it was 2 over square root of 13, now it's square root of 13 over 2. Secant, or cosine, was 3 over square root of 13, now it's flipped, so square root of 13 over 3, and there are your 6 trig functions. Okay, now to find the exact value of these expressions without a calculator, basically take this 405, subtract 360. If you do that, you end up with tangent 45, and whatever tangent 45 is, which is our y value over our x value, it'll end up being 1. So the answer for this guy is 1. You can double check with your calculator on this. Cosine 420, the exact same thing. You end up as cosine of 60, which I believe is 1/2. Something happened. Camera froze. Hello. This is annoying. So, not really sure what happened with the technical stuff, but we're back online anyway. So, cosine of 420 is 1/2 because it's the same as cosine 60. Now, sine 750, if you subtract 360, that's still too big, so you'd have to subtract another 360 to give us, to be sine of 30, which ends up being 1/2 again. Cosecant of 390 is cosecant of 60, which is the same as 1 over sine of 60. So this is the same as 1 over square root of 3 over 2, which is the same as 2 over square root of 3, which is the same as 2 square root of 3 over 3, if you would multiply top by square root of 3 and bottom by square root of 3. Secant of 450 is the same as secant of 90, which is the same as 1 over cosine 90, which is the same as our x value, so 1 over 0, and you can't have 0 in the denominator, so undefined. Cotangent is 765. Once again, we subtract 360, so that's cotangent of 105. I'm sorry, 30, no. So 765 minus 3, I'm sorry, is 405. Sorry, brain fart. Which is the same as subtract 360 again. Cotangent of 45, which is the same as 1 over tangent of 45, and tangent of 45 is 1, so 1 over 1, so that's 1. Okay, now we need to graph this guy right here. Okay, to graph him, okay, once again, here's our graph. Okay, we want to figure out our amplitude, which is this guy, so 2 and negative 2. Okay, so now what we are doing is we are looking for our period, which is 2 pi over a half, which is the same as 2 pi times 2. So 4 pi is our period. So here's 4 pi. So that means this is 2 pi, 3 pi, 1 pi. Now, this is going to start over here, and this is a sine graph, so it starts here. Now, it doesn't have any vertical shift or any phase shift, so it does start here. It peaks here, crosses back over here, valleys here, and then restarts there. And let me move this camera so you get a better. So starts here, peak, cross, valley here. So curve it, cross, down, and back up. And once again, it would do this and do that. Okay, so there's the graph for that. Now to find the amplitude, period, and phase shift of this guy, the amplitude is the absolute value right here, so amplitude is equal to 3. The period is equal to 2 pi over negative 2. So our period is actually going to be negative pi, but a period is a time of distance, so you can say it's just pi. Our phase shift is negative this guy, so negative pi over 2, over this negative 2, which is the same as negative pi over 2 times 1 over negative 2. Right? Dividing by 1, so multiply by the reciprocal. Yep, that's good. So what we do is now end up being negative pi over negative 4, which is the same as pi over 4. So our phase shift is pi over 4. So here's our graph. Our period is pi. So this is pi over 2, pi over 4, 3 pi over 4, and our phase shift. Now this is a sine graph, so it would start here, but because this has shifted to the right pi over 4, it actually is going to start here. Okay? 3, negative 3, peaks, crosses, valleys, and then so peaks, crosses, this will also valley here. So this will cross here, come down and do that. So there is the graph for number 11. Now number 12, we're actually going to use data from our book. Okay, once again, page 590, number 31, and we're going to write a sine graph from this. Now, number 31 says it's the following data represents the average monthly temperature for Indianapolis, Indiana. So we have 25.5, 29.6, 41.4, 52.4. Let's try to straighten this up. This is probably driving those of you who are OCD up the wazoo. To me, whoop-de-doo. Okay, 62.8, 71.9, 75.4, 73.2, 66.6, 54.7, 43, and 30.9. Now, first things first, to write this, we need to come up with our amplitude. Okay, and our amplitude is our largest data, subtract the smallest data, divide by 2. So our largest data ends up being 75.4. So 75.4, subtract our lowest data, which is 25.5, over 2, and that ends up being, I have my phone now, so 75.4 minus 25.5, that's 49.9, divided by 2 gives us 24.95, so that's our amplitude. Okay, our period is 12 months, so 12 months. Our phase shift we'll talk about here in a minute, and we also have a vertical shift. Now, for a vertical shift, this is the largest plus the smallest divided by 2. So our largest 75.4, but we're going to add 25.5, so 75.4 plus 25.5. Divide that by 2, and that'll give us our vertical shift. So 75.4 plus 25.5 is 100.9. Divide that by 2. Nope. So 100.9 divided by 2 gives us 50.45. So we're shifting this up 50.45. So here, I'm going to do a dotted line just for our thing. And so this is actually going to be 50.45. Now our amplitude is 24.95, so that's going to be 24.95 above and 24.95 below. So plus 24.95, that gives us our 75.4. It's always good to double check these. And then our lowest is going to be this 25.5. Now, this is January, February, March, April, May, June, July. My computer likes to go to sleep. I don't know why. So our July is our hottest month, and January is our coldest month. Now, our phase shift, here's 12 months. So here's 6 months, 3 months, 9 months. Now, our phase shift ends up being, well, this is a sine graph, so we would start here, up here, down here, boom there, and here. But our phase shift is actually going to be, our peak was at 3, now our peak is going to be at 7. So we're actually phase shifting 4 months. So where this was here, now is here. That's there. So what would have crossed here is now at 10 months. So 7, so 4, 7, 10. And then what would have been at 12 which is down at the bottom, now is over. Okay, so we're good to go. So what it does is it kind of comes up and then it crosses here. I looked at that point for a minute. Peaks here, crosses here, and it doesn't quite get to the bottom because it still has a little bit here. And that essentially is our sine graph. Now to write this as an equation, our amplitude, so we would have 24.95 sine, and just so you know, the equation will be bonus. 24.95 sine of our k, which is 360 which is 2 pi over k is equal to our period, which is 12. So 2 pi over 1/6 pi actually gives us 12. So 1/6 pi theta. Now our phase shift was 4 months, so that ends up being negative b over 1/6 pi equals 4. So negative what over 1/6 pi gives us 4. Well, pi is going to have to be up here. And 24 pi, because 24 divided by 6 ends up being 4. The pi's cancel. So plus 24 pi, and then plus our vertical shift, which is, so this is part of that, plus 50.45. So here is your equation for that. Here's the graph. This is bonus. So that pretty much wraps that up. I know this is long, cumbersome, and I'm really I know there's spots that are dead with me doing this and that. I'm not going to spend the time editing it because you can fast forward to the points that you need to. I hope this was helpful. I hope this was insightful. And good luck on your test when you take it.